I'm Tom Williams from Colorado School of Mines, and today I'll be presenting on deconstructed trustee theory. Imagine you are in an airport flying somewhere, I don't know, England or Boulder, Colorado for some reason. And as you are walking through this airport, you're greeted by a robot that introduces itself as Alex and suggests you follow it and it'll help you out. Whether or not you choose to follow this robot depends, of course, on whether or not you trust it. Trust has been a huge research question in the human-robot interaction literature. Some HRI researchers have studied human-robot trust using theories and methods from social psychology, thinking that maybe we should think about human-robot trust the same way that we think about how people trust other people. Other HRI researchers have looked at human-robot trust using theories and methods from human factors psychology, reasoning that maybe we should be looking at human-robot trust the same way that researchers have looked at other types of human-machine trust outside of the context of human-robot interaction. However, the new ontological category hypothesis suggests that we need to be thinking about robots in a substantially different way from how we think about other people or how we think about other machines, and that robots really represent a fundamentally distinct category, neither fully agentic nor fully technological, in a unique position somewhere between these two categories. Recently, other HRI researchers have been combining methods from these two different fields in order to develop new ways of studying human-robot trust that fit this new ontological category. Mala and Ullman, for example, have recently presented their multidimensional measure of trust, which combines notions of moral trust and capacity trust in order to study these different dimensions together. We argue, however, that all these previous ways of studying human-robot trust have made presuppositions that need to be interrogated. We argue that all these previous approaches to human-robot trust presuppose that we know who we are talking about trusting. It seems obvious. We're talking about how much people trust the robot. But what do we mean by the robot? Who are we talking about trusting in the first place? Are we talking about the physical structure of the robot, the physical entity that people see? Or are we talking about the agent or identity that people think they're interacting with? In the airline context, for example, are people deciding whether or not to follow this robot based off of their trust in the physical platform in front of them, or in Alex, this identity or personality or agent that has introduced itself to them? Now, these may seem like the same thing, but they're not. We can typically think of humans as having a single body, a single mind, and a single identity we present. However, there's been a lot of really exciting recent research in the HRI literature looking at how these concepts of mind, body, and identity need not be inextricably linked in robotic systems. A configuration that lots of us are probably familiar with is the idea of one-for-all embodiment, where you have a single, ostensibly intelligent system simultaneously embodied in a bunch of different bodies. This is the case, for example, in Amazon's Alexa, which is simultaneously embodied across lots of devices in lots of people's homes. We would expect that different levels of trust would be built up in the different physical devices that are in people's houses versus the trust that people have with the agent that's up in the cloud. Of course, in HRI, these aren't the types of situations we normally study. We normally study situations in which we have a single robot with a single mind projecting a single identity. We argue that people should be building up different levels of trust with the identities that they feel like they're interacting with versus the physical bodies that they're seeing. For example, let's say you're in a situation where there's 3 robots in front of you. There's Alex the robot, there's Avery the robot, and there's Adrian the robot. We would expect that you would build up different levels of trust with each of those robot bodies and each of those robot identities. Ha! However, I just lied to you and tricked you. I just told you that there were 3 robot bodies here, each with their own intelligence. Just because you see 3 robot bodies that all present themselves as having 3 names doesn't necessarily mean, of course, that these are actually distinct systems. It's perfectly reasonable that those 3 robots may be networked together. They may be part of a single distributed system. There may be one cognitive architecture that is controlling all 3 of those bodies. So all this leads us to this idea of deconstructed trustee theory. The idea that when we think about human-robot trust, we should be thinking separately about trust in bodies versus trust in identities. This theory has 2 main commitments. The notion of the trustee in theories of human-robot trust must be deconstructed into multiple loci of trust, such as body trust and identity trust. We should be looking at multiple dimensions of human-robot trust, like capacity trust versus moral trust, but we also need to be looking at these different loci of trust. This theory should predict that different levels of trust may be built and lost in each of a trustee's constituent trust loci. Different robot identity performance strategies, that is, robots that are designed to communicate the idea that there's a single identity tied to a single body, versus robots that communicate a different configuration, people may believe it's more or less reasonable to even think about developing trust in different trust loci. Our third prediction is that different trust-affecting actions, that is blameworthy versus praiseworthy actions, may differentially affect the concreteness and or trust built in each of those loci. Blameworthy actions should lead people to thinking about whether or not they should be trusted. In this work, we specifically aim to test 3 hypotheses built out of these general predictions. Our first hypothesis is that robots that use body identity dissociating communication policies that break the illusion of human-like one-to-one body identity alignment will be less likely to be viewed as agents in which trust can be placed than robots that use body identity associating communications that actively maintain this illusion. Our second hypothesis is that robots that use body identity dissociating communication policies will have greater differences in perceived trustworthiness of their bodies and identities than robots that use body identity associating communication policies. And our last hypothesis is that robots that take blameworthy actions will be more likely to be viewed as agents in which trust, albeit less trust, could be placed due to more concretized mental representations than robots that take only praiseworthy actions. And such robots will have more differentiated body versus identity trust. To test these hypotheses, we ran an experiment with people on Mechanical Turk watching videos of a purple robot that introduced itself as Bumble, a yellow robot that introduced itself as Honey. After the robots introduce themselves, the purple robot flies off to perform some inspection task. The yellow robot reports that the other robot has either caused an air leak or it's discovered an air leak. And these trust building or trust damaging actions get reported to the user in one of 2 ways. In the first strategy, the robot maintains the illusion these are different robots, even though they're really part of the same integrated system. Bumble has caused an air leak, or Bumble has discovered an air leak. In the second strategy, we break this illusion. The other robot's voice comes out of the yellow body and says, "This is Bumble. I have caused an air leak." Or, "This is Bumble. I've discovered an air leak." After people watched one of these 4 videos, we had them fill out the MDMT capacity trust survey. And because we wanted to separately study body trust and identity trust, we came up with a sort of clever way of separately measuring trust in body and trust in identity. And so what did we find with our 210 participants on Mechanical Turk? Do these illusion-breaking communication policies weaken trust loci? Maybe. Under communication strategies that broke the illusion, people found the yellow body that was used for communication less reasonable to think about trusting or distrusting. These results suggest that robots that can cede control of their bodies to other identities also cede their potential for capability trust. Our second hypothesis was that communication policies that break the illusion of one-to-one body identity alignment lead to divergence between perceived trustworthiness of body and perceived trustworthiness of identity. And what we found was actually, no, the divergence happened anyways. It wasn't dependent on the communication policy. Our third hypothesis was that blameworthy actions should strengthen trust loci and lead to increased divergence between body trust and identity trust. Blameworthy actions may have led people to find the identity that was taking these blameworthy actions to be more reasonable, to be something that you should think about trusting or distrusting than when praiseworthy actions were taken. Moreover, we did find that blameworthy actions exacerbated differences between body and identity trust for the action-taking robot. When the robot was causing air leaks, there was a much larger difference between body and identity trust than when the robot was finding these air leaks. When a robot performs a blameworthy action, humans' moral cognitive processes may lead them to identify which aspect of that robot is to blame for that action, which results in greater trust losses in that particular loci of trust. The high-level takeaways are: 1, the connection between robot body and identity in multi-robot distributed systems is a design choice. Designers have a lot of power in terms of what mental models people build with respect to their robot. 2nd, we can separately measure body trust and identity trust. And finally, building on these ideas, we presented deconstructed trustee theory. So thank you for listening. Please read the paper, and you can always visit mirrorlab.minds.edu to learn more about this research and the other research we're doing in our lab. Thank you.